Okay, so what are we planning to learn today? We are learning index laws. Now, what is an index? That is the first question before we really understand the laws, right? So what is an index? Index actually means power, right? So if I write, let's say 2 raised to the power of 3, so this 2 is the base and 3 is the power or index. And combined, this 2 raised to the power 3 is known as exponential. Exponential. Now, let's understand the basic laws of indices. So the first law, law number 1, is the multiplication law. It tells us that if there are two indices, two exponentials coming together, multiplying with each other with the same base. So here the base is A, index is n. Base is A, index is n. We're multiplying. So the result is we add them, add the indices. So 2 raised to the power 3 times 2 raised to the power 2 is not 2 raised to the power 6. It is 2 raised to the power of 3 plus 2, which is 2 raised to the power of 5. That is the first law. Law 2 is division. If you have two indices, two exponentials dividing each other with the same base, the powers subtract. So what it actually means is if you have 2 raised to the power of, let's say, 5 over 2 raised to the power of 2, the answer is 2 raised to the power 5 minus 2 equals to 2 raised to the power of 3. Then you have law 3. Any base raised to the power of 0 is always 1. Any base, anything in the world raised to the power of 0, any number, anything, fraction, rational, irrational, if you raise it to the power of 0, I don't care about the base. I just write 1. So it actually means, let's say 2 raised to the power of 0, it will give you a 1. So whenever you see anything raised to the power of 0, the answer is 1. Law 4. If you have indices multiplying each other, within the brackets, right? If you've got an overlapping indices, which is one inside the bracket, one outside the bracket, but the base is only 1. Now you multiply them. Let's say n times n. So what it means is, let's say I'm just taking 2 as an example here, right? As a base. 2 raised to the power of 3 and raised to the power of 2. So now this will multiply to become a 6. You see, there's a subtle difference between how this behaves and how this behaves. Here you have two indices being multiplied together, obviously getting added because you've got two bases. The bases are 2. There are 2 different exponentials coming together. Here the exponential is just 1. It's just that they're powered twice. So you multiply them. Now, I'll take a different page. To now, law 5. Law 4, law 5. Now, if you have two numbers multiplied together, so they're basically one base, which is a factorized base, raised to the power of an exponent. So you can separate them out. So what it actually means is 2 times 3, 2 times 3 raised to the power of 6 will be 2 raised to the power of 6 times 3 raised to the power of 6. So this is a factorized base. Now this will work out exactly same as 3 times 2 is 6. 6 raised to the power of 6 will give you the same answer. But if you're factorizing your base, then the powers go independently on every factor. Then you have law 6. Very similar to multiplication is division. If you have a fraction as a base, raised to the power of something, an index. So when you open up the bracket, it can go independently across numerator and denominator. So what it means is if I have 2 over 3 raised to the power of 2, it will be 2 raised to the power of 2 and 3 raised to the power of 2. And then law 7 is the negative index. So if you have a raised to the power of minus m, now your index is a negative number. There's nothing called negative power. Power is always positive. And how do you make it positive? You reciprocate the given exponential. You take the numerator to become a denominator, and the powers flip. In the sense, their signs flip. Negative becomes positive, positive becomes negative. It's other way around as well. So if you've got 1 over or a raised to the power of negative m, it becomes a raised to the power of m. You see the difference here. From denominator, this moves to numerator, power changes its sign. From denominator to numerator, from numerator to denominator, power changes its sign. So whenever you make the exponential itself, whether you flip it, the signs reverse. Then there's the concept of, all of these laws are absolutely fine when your m, whether your m is a whole number or a fraction or a rational number or fractions. So the rules will still stay the same. In that case, the concept of surds come into the picture. So if you have a raised to the power of half, in the world of surds, I write it as square root of a. If you have a raised to the power of 1 by 3, I write cube root of a. So rational indices give birth to surds. That is how we connect the dots between exponentials and surds. So I can generalize this to say a raised to the power of 1 over n is the nth root of a. This is surd. This is the starting point of any surd. Last but not the least, if you have a raised to the power of m over n, then you can apply one of the laws here in the reverse fashion. I apply law 6 in the reverse fashion, or so law 5. And I can say 1 over n inside times n. You see? When you've got this, it goes on top. And so not the law, this is the law 4 that I'm trying to implement. So law 4 tells you that you can take a bit of one factor of the power inside and one factor of the power outside. So that is what I've done here. So I've applied law 4 here. And this being the nth root of a, so the answer would be the nth root of a raised to the power of n. So this, in a very nutshell, is what your laws of indices and your fractional indices work. I hope that makes sense, right? Cool. All right. Thank you.